In this brief video, we will take a look at how to solve inequalities with the TI-30XS multi-view calculator. Before viewing this video, you should also view the video titled Solving Linear Equations Example 1, which is located at the link that I have shown on the slide on YouTube. The reason why I encourage you to watch this video first is it demonstrates many of the techniques I will use with the calculator for entering algebraic expressions and solving them for a single value of the variable. Let's look at trying to solve the following sample high-set inequality practice problem. Before I begin, let me draw a line down the paper that separates the left and right-hand sides of the inequality. Also notice that I've underlined the two values, 49 and 25/100ths and 492 and 5/10ths, that appear as part of each of the four answers. These are the two values that I need to test in the inequality to see whether the left-hand and the right-hand side of the inequalities are equal at either of these two values, because those values represent what we call the boundary values for the solutions of the variable x that will satisfy this inequality. So I'm going to start with x equals 49 and 25/100ths, and I'm going to find the value of the left and right hand sides of the inequality at that particular value. So getting my calculator ready, I'm going to go ahead and turn that on, clear the screen. I'm going to go ahead and enter, first of all, the value x equals 49 and 25/100ths. And we can easily do that by typing it in, 49 and 25/100ths. And then I'm going to move the calculator up so you can see that I'm going to hit the store button, STO, to store that, and then the XYZTABC button to show an X on the screen. Remember that if we hit that button multiple times, it just changes the letter that appears for the value of the variable. But I want X. I'm going to hit Enter. That value is now stored in the calculator for the variable x. And now all I need to do is enter in the left and the right hand side expressions to see what their value is when x equals 49 and 25/100ths. So let's start by entering in the left hand side. So let's move my calculator over here so you can see me entering that. So I've got -3 parentheses 4x minus 8 2/10ths. I'm going to close the parenthesis, and then I'm going to hit the Enter key, and I get a value of -566 and 4/10ths. So let me go ahead and put that value in here, -566 and 4/10ths. That is what this expression is equal to when x is 49 and 25/100ths. Now let's do the same thing for the right-hand side of the inequality. So I'm going to go ahead and enter that expression, -11 and 98/100ths, x plus, and then I use the fraction key with the second function button to get at the mixed number entry, 14, move the cursor over, 3, move the cursor down, fourths, and then move the cursor over and hit Enter, and I get a value of -575, -575, and 265 thousandths. Okay, so that's what the right-hand side algebraic expression is equal to when x is 49 and 25/100ths. Now notice that this value is actually less than, so -566 and 4/10ths is greater than -575 and 265 thousandths. We've just learned a lot of valuable information. First of all, we know that these two answers cannot be correct, because if 49 and 25/100ths was the boundary value, I should have gotten an equality here, and I did not. Also, at this point, I know that 49 and 25/100ths did not satisfy this inequality, so therefore C cannot be correct, because 49 and 25/100ths is less than 492 and 5/10ths. So therefore it should have worked if that was an appropriate value. So at this point, I know that the answer is D, and I could quit right there and move on to the next problem. But since this is a teaching video, I want to make sure you see that this really does work. So the next thing I'm going to try is let's let x equal 492 and 5/10. Let's plug that into the calculator. I'm going to put that in for the variable value of x. So I'm going to put in 492 and 5/10. I'm going to store that in x. And when I do that, it is now stored in the calculator for the variable value of x. Then I go back up to the two expressions I entered before using the cursor key. Here's the left-hand expression from the problem. I hit enter and enter again. I get a value of negative 5,885 and 4/10. Remember again, that's the value of the expression, negative 3 times 4x minus 8 and 2/10 in parentheses. And now I go ahead and do the same thing for the right-hand expression. So the right-hand expression, here it is, enter, enter, and notice I get exactly the same value, which is exactly what we should have seen if this number is the boundary value. So these are equal. Therefore, I now know that this value is the boundary value for this inequality. Now again, to finish this off, let's make sure that this answer is correct by picking a value for x that's different. Let's pick x equal 1,000. That's a big number. It's certainly bigger than 492 and 5/10. So I'm going to plug that in and store it. Store that in x. And, oh, I forgot to hit the store button. Let me go back. Store that in for x. Enter. And then now I'm going to go back to the left-hand expression and see what its value is when x is 1,000. The value is negative 11,975 and 4/10. And now I'm going to do the same thing for the right-hand expression. So using the calculator again, I move up using the cursor key. Up, I went too far. There it is. Hit enter. Enter again. I get negative 11,965 and 25 hundredths. And sure enough, the left-hand side number is less than the right-hand side number. So I am now convinced that we have found the correct answer, which is D, x greater than 492 and 5/10.